Okay, we can get started. And thank you for joining this webinar on what if you could block the next DJ Actions breach, where we are going to be introducing workflow run policies, a new capability. My name is Varun Sharma, and I'm the CEO and co-founder of StepSecurity.
Hello everyone, it's great to have you all join our webinar. My name is Ashish Kurmi and I'm a co-founder and CTO of StepSecurity. We go to the next slide. Before we get started with our webinar, just wanted to quickly share that we will be attending Black Hat this year, where we'll be presenting how we discovered the TJ Actions change files CI/CD supply chain attack and our key learnings from that incident. If you're planning to attend, this conference, please do stop by, and we would love to meet you in person. This is the agenda we have for our webinar. First, we'll introduce you to the broader step security platform, which will take about 10 minutes. And then after that, we will go over real world GitHub Action security scenarios and how workflow and policies can prevent them, which will take about 40 minutes. And we'll keep the last 10 minutes for Q&A. With that, let's get started with the first section, where we'll provide you with an overview of the step security platform. So we speak with a lot of enterprises and we see this situation again and again, which is enterprises typically invest heavily in code or application security by using solutions like Sneak, GitHub Advanced Security, Veracode, and so on. Similarly, on the other side, enterprises invest heavily in cloud or infrastructure security by using solutions like Wiz, Palo Alto, and other CSPM IDS solutions. But CI/CD, which is the crucial link between these two environments, it remains unprotected. Some organizations try to use their existing code or cloud security solutions to defend their CI/CD, but these solutions were never built for the CI/CD context, and they don't provide any protection against CI/CD supply chain attacks. And it's no surprise that bad actors are now actively going after CI/CD, and we have seen a sharp rise in the number of CI/CD security attacks. And on this slide, we have given a few examples. So the first one is the TJ Actions breach, which happened in March this year, where a very popular third-party GitHub Actions was compromised. And due to this breach, more than 24,000 open source repositories were impacted. In February, an organization called Kong got breached in their GitHub Actions environment. And through this breach, the adversaries published a backdoored Docker image in their official Docker Hub repository, which got downloaded by several of their customers. Similarly, in December, Ultralytics, which is a very popular AI ML processing library, got breached in their GitHub Actions environment. And through this breach, the adversaries were able to publish a backdoor version of their library. So we can do a quick exercise, and on this slide we have shown a typical GitHub Actions workflow, which consists of 3 steps. So at line 53, we are checking out the source code. And then at line 56, we log into our AWS ECR account. And then at line 64, we create a Docker image and then we push it to our AWS ECR registry. So let's, figure out all the things that can go wrong here. So CI/CD fundamentally is a high risk environment because by design, it has access to admin cloud credentials, as you can see at line 16. Similarly, CI/CD produces production builds that either run in your own environment or that get shipped out to your customers. And we can see that at line 64. And if you look at a typical GitHub Actions workflow, it executes third-party GitHub Actions. So now you have a lot of untrusted third-party code running in this highly privileged environment, which makes it a high-risk environment. So before I give you an overview of different capabilities offered by the StepSecurity platform, let me walk you through the specific problems that we are going after. And the first one is that when it comes to the use of third-party GitHub Actions, typically there is friction between security and developers because developers want to use these third-party actions as it makes them productive, they can move faster, Whereas security, on the other hand, is worried about the additional risks that these third party actions bring on. In this case, unfortunately, security doesn't really have a good choice, because either they can deny the use of these third party actions, which leads to developer frustration, or they can accept the use of these third party actions, which increases their overall risk posture. Some organizations, try to fork and maintain their own copies of third party actions that they use, but maintenance of these third party actions in the long term is an expensive process. Second, CI/CD runners are doing a lot of privileged operations. They are interacting with your cloud control plane. They have access to your proprietary code repositories. They produce production builds. Yet most organizations have zero runtime visibility into these runners. So they have security agents for their desktops and laptops, and similarly they use EDR and other security agents for their cloud workloads. But CI/CD runners, the instances that are doing all these privileged operations typically remain unprotected. So organizations, for example, don't know what kind of network calls are being made from these CI/CD runners, what kind of processes are being created, what kind of file events are happening. And since they don't have any runtime network visibility, typically these runners are allowed to talk to any endpoint on the internet. They don't have any network egress filtering in place. And finally, GitHub has published a comprehensive set of guidelines to protect GitHub Actions workflow YAML files, but detecting security misconfigurations and specifically remediating them at scale is a challenging task for organizations. So this slide talks about the key features offered by the StepSecurity platform. And we view CI/CD as something that consists of three distinct layers. And each of these layers have their own set of unique security challenges. So we can start from the bottom layer. The first layer is CI/CD infrastructure or CI/CD runner. To protect this layer, our platform provides a real-time prevention of CI/CD security attacks. And conceptually, we can think of this like CrowdStrike or Lacework or Wiz Sensor, but purpose built for CI/CD. Our solution for this layer is called Hardened Runner. And in fact, Hardened Runner was a platform component that detected the TJ Actions CI/CD supply chain attack. We were the first one to detect the TJ Actions security breach. And the way it works is Hardened Runner gets deployed on your runner instance, whether it's self-hosted or GitHub hosted, before any pipeline code is executed. And then it starts monitoring the runtime behavior. So it looks at the network calls that are being made, the processes that are being created, and so on. And then all these runtime events are correlated with build logs in our backend to provide the CI/CD context. And then based on that, the platform generates security detections and insights. In the middle, the second layer is pipeline as code. And to protect this layer, our platform not only detects security misconfigurations, but it can also provide automated remediations through pull requests. So for example, when the TJ Actions incident happened, everyone was scrambling to pin their GitHub Actions. And using this platform capability, our customers were able to pin all of their actions in a matter of a couple of hours. The second feature that I would like to call out here is the workflow run policy, which we are going to cover in this webinar, where you can define uh, compliance rules for your workflow runs. And if a workflow run does not meet those requirements, it will be actively blocked. At the top, the third layer is third-party GitHub Actions or CI/CD pipeline components. And at this layer, our platform provides several capabilities. So first of all, it provides a comprehensive inventory of all the actions that are in use, along with which particular version or which particular commit shas that are being used. And when the TJ Action incident happened, our enterprise customers could use this feature to figure out whether they were using the vulnerable versions or not. In addition, our platform provides a security score for all the third-party actions that are out there. And using this score, you can determine whether you should be using a particular action or not. When we started rating popular third-party actions, we realized that most of the popular third-party actions have a low security score because these actions come from individual hobby developers. And unfortunately, these developers don't have enough resources to maintain them in good standing. So to provide a solution to our enterprise customers, we started offering step security maintained actions. So step security maintained actions are secure drop-in replacements for risky third-party actions. And the way it works is, behind the scene, we create a fork of these third-party actions into our own GitHub organization. But before we do that, we do a manual code review to make sure that it does not have any known security vulnerabilities. We run a bunch of security tools, we upgrade all the dependencies, we implement a secure release pipeline, and then we maintain these actions in good standing going forward. So, using our platform capabilities at this layer, our enterprise customers essentially build an internal GitHub Actions marketplace, which is a set of trusted, vetted third party actions that their developers can freely use. So when the TJ action incident happened, everyone was looking for a safe way to use the TJ actions change files action. And back then we also onboarded this action as a maintained action. But since the entire community was trying to recover from this incident, we actually made that action free. That maintained action is available for everyone to use. With that, now we can deep dive into workflow run policies. Let me stop sharing.
I can go ahead and share my screen. And now that Ashish shared a high-level overview of our platform, we can next look into the details of workflow run policies. And workflow run policies essentially allow you to block workflows that don't meet your organization's security requirements. So in the next few slides, we're going to look at 4 different scenarios where workflow run policies can be used. And in each case, we look at what is the problem that we are trying to solve with it, and how can a workflow run policy solve that, and then we'll go through a demo to see that in action. So the first scenario is when a third-party GitHub action gets compromised. And for this, we can look at examples like TJ Actions or reviewdog, where both these actions were compromised recently. And in both the cases, starting with the first case of TJ Actions, when we detected the compromise, we immediately alerted our customers about it via Slack or email. And then they had to hunt down every usage of the action across the repositories. In fact, first they had to look at the alert that was sent to them, and then they had to realize that this incident has happened. Then they had to look for all the instances across the repositories and then disable those workflows manually. And as you can imagine, that this whole process is slow and requires a lot of manual work. And what made it even harder was the fact that this compromise was actually detected on a Friday evening. And so a lot of people were not available at that time. And the incident response went into the weekend. So now the question is that the next time an incident like this happens, how can the incident response be more automated? And that is one of the areas where the workflow run policy can help. And so one kind of this workflow run policy is the compromised actions policy. And so the way this works is that at StepSecurity, we maintain a list of known compromised actions. And anytime we detect that a new action has been compromised, we are going to add it to this list. And if you have deployed this compromised actions policy, what that means is that any workflow that is using a compromised action will automatically and immediately be blocked without the need for any manual intervention. And so next time a TJ actions kind of scenario happens and a third party action is compromised, you don't have to worry about immediately going and trying to investigate it, knowing that the compromised actions policy would have started blocking instances wherever it is being used. And this makes the whole incident response process more automatic. So now let's look at a demo of this compromised actions policy in action. And so this is what our dashboard looks like. And here I'm going to go ahead and create a new policy. And you can see that currently we have these 4 policy types. So I'm going to choose the compromised actions policy and I can give it a name. Now, each of these policies you can either run in enforce or dry run mode. So I'll keep it at enforce. And then you can apply these policies to all repositories or to specific repositories. And so in this case, I'm going to apply it to a specific repository. So now this compromised actions policy has been applied, and we can see what happens when we run a workflow which is using a compromised action. So in this case, this is an example of a workflow. And this particular action, the dummy compromised action, is just a action that we've developed which doesn't really do anything, but it is always added to the list of compromised actions. So you can actually test out this policy. So now I'm going to go ahead and run this workflow. And the scenario here is that, another action has been compromised. In this case, it's this dummy compromised action. And now, one of the workflow runs and it is using that action. And you will see that as soon as this workflow starts, the build is cancelled and it gets cancelled because of this policy. So in here, we can see that this run that was just started, it is cancelled. And the reason it is cancelled is because it was using this compromised action. And so we can now go back to the dashboard and look at the policy evaluations. And here we can see that this particular run was blocked, and it shows you that this was blocked because the compromised actions policy was not met. And it then also shows you what particular action caused it to be blocked. So with this deployed, next time a third-party action gets compromised, the whole incident response becomes much more streamlined and automatic. So with that, we can move on to the next scenario and discuss a workflow run policy related to this. So the next scenario is where a developer or a bot credential is compromised. Now, in this case, what typically happens is that an attacker gets hold of a developer credential, which could be a personal access token or a bot credential, and then uses it to create a new workflow in a non-protected branch to run a GitHub Actions workflow to exfiltrate credentials. And in fact, this is a very common red team tactic, and it was also used in the recent Grafana security incident where one of the bot accounts credentials was first compromised, and then it was used to create a new workflow to exfiltrate credentials. And the reason this works is because by default, anyone that has write access to a repository can create a workflow. And unless you're using publishing rules, deployment rules, or environments, those workflows will have access to the GitHub Action secrets and they can access them and exfiltrate them. So for this scenario, we have a secrets exfiltration policy. And the way that works is that only approved workflows are allowed to run. And what that means is that any new workflow or changed workflow that accesses secrets and is not approved will automatically be blocked. And workflows in the default branch are automatically approved because the assumption is that there is branch protection set up and someone must have reviewed those workflows before they are merged into the default branch. And so changes to workflows need to be approved by another person, which is similar to a pull request process. So now let's look at a demo of the secrets exfiltration policy in action. So here I'm going to go and create a new policy. And this time I'm going to choose a secret exfiltration policy. Now with these workflow run policies, you can deploy multiple policies at the same time, and they can target the same set of repositories. And each of them will be evaluated. And if any of one of them fails, the workflow run will be blocked. So in this case, I'm going to call it secret exfiltration policy. And again, I'm going to apply it to this repository. And I'll go ahead and save this. Now, in this case, the scenario is that there is a workflow that I'm going to execute, which is going to try to access credentials, and it's going to try to exfiltrate them. And the scenario here is that, I have gotten write access to this repository, through a developer pat compromise or a bot account compromise that had access to this repository. And now I'm trying to simulate how an attacker might exfiltrate credentials. So in this case, I've created this workflow, and this is accessing the secrets object, and then it's going to upload it as an artifact. And it could have also just sent it over the network. And now, as an attacker, I obviously want to run this in a way which is stealthy. So I'm going to commit this to a new branch. And in a real scenario, after the exfiltration is done, I would delete this branch and delete the workflow run. But here I'm going to go ahead and create this workflow, and I'm not going to create the pull request. And so this should cause the workflow to run. But again, you can see that because of the secret exfiltration policy, this workflow has been immediately blocked. So it was not allowed to run. And so this attempt to exfiltrate credentials has been blocked. Now, there is also a scenario where the developers actually want to change certain workflows, and their accounts have not been compromised, but it's just a happy path where you want to make changes to workflow files. And in that case, whenever a pull request is created, which is changing a workflow file, and a workflow run gets blocked, you will get a pull request comment. And then that particular workflow can be allowed to run if any other developer adds a workflow's approved label to that pull request. And that is basically a way to approve that workflow, to say that this has been reviewed and it should be allowed to run. In the future, we are going to also enable approving this through a pull request comment. So now we can go and look at the policy evaluations. And here you can see that this is the secret exfiltration scenario. And in this case, there was no compromised action. So that policy passed, but the secret exfiltration policy failed because the run had unreviewed workflow, which referenced an action secret. So now we've looked at a couple of scenarios where workflow run policies help. Let's go to the next one, which is a scenario where forked or internal actions go unreviewed. And the scenario here is that you are using GitHub's allow list feature to allow a set of actions in your organization, and you have set up a review process. So anytime a new action needs to be used, it goes through a review process, and someone looks at it, reviews it, and if they find it to be good, it gets added to the allow list. But the problem here is that the GitHub allow list feature implicitly allows actions that are in that same org. And so developers can actually fork risky public actions into the org and use them. And by doing that, it kind of bypasses the whole review process. And this is why some of our customers actually wanted us to implement this through a workflow run policy. The other scenario is that with the GitHub's allow list feature, you can only enforce it at an organization level or at an enterprise level, but not at a repository level. So if you haven't already set up the allowed list and you have a lot of usage of different actions, it becomes hard to enforce it at an organization level because you have to collect all that data and then enforce it while the actions are already being used. And and the fact that there is no way to apply it at a repository level makes it harder to get started with an allowed list. So to solve these issues, as part of the workflow run policies, we have an allowed actions policy. And in here, you can define an allow list of approved actions, and then you can enforce it either at the whole organization or per repository. And with this policy, internal actions are not implicitly trusted. So just because an action is in that same org doesn't mean that it will automatically be allowed to run. So now let's look at an example of the allowed actions policy. So here I'm going to go ahead and create a new policy. And this time I'm going to choose the allowed actions policy. And I'm going to set it to enforce again. Now here there are multiple ways to add actions to the allowed list. You can either manually type it in here and add it, or you can look at the usage across your organization, or you can look at the usage at a repository level. So here I'm going to look at the usage at this for this repository, and I can see that there is this internal action which is being used, and there are a few other actions. So in this case, I'm going to add the checkout action to the allowed list, and I'm going to add harden runner to the allowed list, but I'm not going to add the internal action. And so this is what our allowed list looks like. And then I'm going to go ahead and apply this policy at a repository level to this run policy demo repository. And now we can go back and try to run a workflow which uses an internal action. So in this scenario, you can see that it has the harden runner action, which is allowed as per policy, and it has the checkout action, which is allowed as per policy, but this internal action is not allowed. And so now I'll go ahead and run this workflow. And again, you'll see that this workflow run has been blocked. Now, if the same thing was done through the GitHub Actions allowed list feature, the internal action would have been allowed to run because it implicitly trusts internal actions. So now we can go back and look at the policy evaluation. And in here, we can see that this is the run for which it was blocked because an action was not in the approved list. And here you can click on the details to see that it was this internal action which was not in the approved list. And with that, we are at the last scenario, which is if you have a need to restrict to certain usage to certain runner labels. And the scenario here that we've heard multiple times from our customers is that they don't want to allow the use of GitHub hosted runners on certain repositories. So they have set up self-hosted runners, and due to compliance or security requirement, they only need to use those runners for certain repositories. Or in some cases, they have multiple different types of self-hosted runners, and they want to enforce the usage of specific runner labels for specific repositories. And without any kind of control or policy, it becomes hard to enforce this requirement. And so this is where the runner label policy can be used, where you can define a policy to block the use of specific runner labels, and then you can enforce it again at the repo level or also at the organization level. And if a disallowed label is used in a workflow, it will be blocked automatically. So now we can go back and create a policy of type runner label policy. And in this case, I'm going to disallow the Windows latest runner label. Now, if you want to disallow all of GitHub hosted runners, you can just add the labels for GitHub hosted runners. And or if you want to disallow specific runner types in a given repository, you can add those. And now again, I'm going to go ahead and deploy this policy to the same repository. So now we have 4 different policies applying to that repository, and all of them apply for each run. And if any of them is not met, the workflow run would be blocked. And so now we are going to look at this workflow where Windows latest is being used, and this is to demo how this policy works. So now I'm going to go ahead and run this policy, run this workflow. And again, you can see that the run has been blocked because the runner was using Windows latest, but this was not in the list of allowed runners for this particular repository. And we should see this come up in the policy evaluations where the runner policy was not met, and it was because of this particular runner label that the workflow was blocked. And that brings us to the end of the demo. And with this workflow run policies, we are also in the process of adding additional policies because we have this capability in place where we can block workflow runs if certain criteria is not met. And these are some more resources where you can find more information. And if you have questions, please let us know.